Hello everyone. In this video, we will learn how to parameterize a curve. In other words, if someone gives you an equation in only x and y, well, the best one are the one that y is explicitly function of x, then can you turn this to a parametric equation? So the step is very interesting and simple. And the key here is that take x and make it your parameter. In other words, set x to be t equal to t. Then y is going to be f at t. So I have one equation for x in t, y equation for y in t. This is parametric equation. This is the simplest way to do this parameterization. Let's see this one, this example. So this equation, which is a parabola, we want to parameterize it. Okay, so we start with y equal to f of x, and then we set x equal to our parameter. And then, then y is going to be 2t squared minus 3. This is parameterization of our curve, or at least a graph of the function. Well, something that you have to note is that the parameterization is not unique. For example, we can set x to be any linear function in x, in t, sorry. In general, I mean, you can set this one at plus b when a is not equal to 0. Well, the payoff is that this time when you're trying to write y in terms of t, you have to plug in the whole at plus b. Okay, well, for example, the same equation here, I can go ahead and write it as, say, x is equal to, say, 3t minus 4, and then y is going to be 2 times 3t minus 4 squared minus 3. Well, you can expand it and write it in terms of t, but this is basically the equation. Or you can go ahead, write x equal to t, well, actually I can write something a little bit different, 3 minus t, and y is equal to 2, well, plug this one in for x, well, sorry, this was x, not t, yeah? So this is going to be 2 times 3 minus t squared minus 3. Well, if you simplify, you get 9, 18 minus 6, 12 t plus 2t squared minus 3, and simplify more. Actually, you can do a little bit more. For example, if we are only looking at positive t's, if t is supposed to be in the domain positive, well, then in that case, for example, I can set t to be sorry, here what I meant was x being positive. So if the curve, we want to have part of the curve for which x is positive, you can go ahead and then you can set this one to be equal to function like e to the power t. Okay, and then y is going to be 2 times e to the power t squared minus 3, which is 2 e to the power 2t minus 3. Well, these are all parameterization of the same curve, but different parameterization, as you can see. And you have to note that the parameterization is not only the curve defines the curve, but it defines a direction. For example, this direction and that direction are opposite of each other, because here t grows, x grows, here t grows, x decreases. So the direction is different. Or here we can only get x values by this parameterization, which are bigger than 0. So e to the power t is always positive number. Yeah. And this way you basically have everything. Well, another one is that, well, I can take, for example, x to be ln of t. Here x can be any number, but our parameter can be only positive t's. Yes, all positive t's won't generate any restriction on t, because ln t is covering the whole real lines, real numbers. And then here this will be 2 ln t squared minus 3. Yeah? That's another parameterization. So as you see, well, going at least from graph of a function to parametric equation is not that difficult. You just need to set x to be a function of proper function of t, and then plug that into the function for y.